Let's have a look at interpreting some infrared spectra. On the left hand side there you'll see I've included what you'll see on your data sheet, so looking at the characteristic absorptions, and from the notes here's one that tells us it's an alcohol, but let's have a look at the spectrum, see what we're meant to see from that. So along the bottom there we've got the wave number, so these are characteristic numbers depending on the bond and the bonds which are absorbing the infrared radiation. So different bonds will absorb in different areas. Drawing a line there at around about 1500. So below that indicates the fingerprint region, and this will be a series of absorptions which is specific to individual compounds which your database will pick up. So we don't need to look at anything to the right of 1500, so we'll be focusing on things to the left of it, using the data sheet to look at any characteristic bonds. Let's have a look at what we've got. So I've just highlighted there the absorption around about 3000. Looking on the data sheet we can see fairly confident that that is for a carbon hydrogen absorption, which is not going to be a great surprise in organic molecules, so we're going to expect pretty much everything to have an absorption around about 3000, so let's not get excited about that. So the one that we can get excited about here is the one slightly to the left of that, a broader absorption which I've highlighted in blue. Let's have a look on the data sheet, and we can see around about 3300-ish is an OH absorption specific to alcohols, and the notes tell us it's an alcohol, so just as we'd expect. Another example here, we're told that this is an aldehyde or a ketone, so we're going to expect a carbonyl grouping. Again, I'm drawing a line around about 1500 there, and we're kind of ignoring everything to the right of it. Let's focus on the left. Large absorption down at about 3000. What do we think that is? Yep, so carbon hydrogen again, but the one for an aldehyde and a ketone. So carbon double bond oxygen. There's only one other peak really of any note there, and there it is, coming in around about 1700, so 1680 to 1750. Let's have a look at one more. So cyclohexene, lots of absorptions going on there. There's the one that we've seen before, so that's the carbon hydrogen. So what will cyclohexene have of interest? Well, let's draw the skeletal formula. We've got the carbon-carbon double bond. Let's find that on the data sheet. There it is. Very close to the carbon-oxygen double bond. We just need to be careful if we've got something with one of those in, but fairly small absorption compared to some of the others, but there it is. I've highlighted it in blue, coming in around about 1650, showing us that we've got an alkene. This example is asking us to identify which one is a saturated and which one is a saturated compound. So we're looking for a double bond, carbon-carbon double bond, like in the previous one. So there we go, we're looking for something around about 1620 to 1680. So roughly go down on our spectra around about that point in spectrum number 1. Can you see anything there? I can't. That looks like it doesn't have a double bond. Spectrum 2 certainly looks like it does have a carbon-carbon double bond, so I would be guessing that spectrum 2 is for the unsaturated compound, which is R, whereas spectrum 1 is for the saturated one, which is S.